Hello everyone, I'm Prashant Tunyal. I work as an application scientist at Elucidata, and today I'll be talking about data centricity and NLP, how we can improve the quality of biomolecular data. As you might be aware, data and model are two basic components of any AI system, and both of these components play an important role in like producing your desired result. The AI community, both academic and industry research, has been focused a lot more on improving and iterating the model on benchmark data sets rather than improving the quality of data itself. And this has led to a model centric approach where working on improving the code is the central object while keeping the data same. This also is true for NLP based workflows. Following this approach has led to the creation of big and large ML models like PaLM, Pathways language model by Google, which has about 540 billion parameters. Similarly, the famous GPT-3 by OpenAI has about 175 billion parameters, and even bigger models by OpenAI, NVIDIA, Microsoft, and others are already in pipeline. So this has led to the data being frequently overlooked, and most researchers view the data collection as one-time event, and this has led to crucial data being mishandled and mislabeled. According to research, roughly 3.3% of samples in commonly used data sets across computer vision, natural language, and audio are mislabeled, mostly affecting large models. And even so, data collected within an organization may have a higher chance of mislabeling, as the data and process may not have been reviewed by a wider body of researchers. This leads to a lot of wasted resources because training a large model like GPT-3, it costs a lot of time and money. Also, the large size of the model inherently makes it much more difficult to remove biases that might be present in the training data and impact the analysis. As a result, number of hours are wasted fine-tuning an NLP model based on the faulty data. So here, a data-centric approach in NLP models, it systematically enhances and improves the data sets in order to increase the efficiency of the AI system. So instead of spending resources on collecting more noisy textual data, investments have to be made in improving the data quality by curating clean and consistent labels. Effective implementation of biomolecular data, it requires highly customized models that are trained on good quality healthcare data sets. And to increase the quality of biomolecular data, one can focus on these four following points. That is, improving data label quality, quality checks by subject matter experts, data augmentation, and pre-processing the data. I'll be talking about each of these steps in further detail. So first, we will talk about improving the label quality. Labels, as you might be aware, are specific values that are assigned to the data. During the manual curation process, incorrect labels can be assigned to data, which result in decrease of the model accuracy. So here are some of the examples of textual data labeled differently by two different manual curators. So as you can see the description, our findings indicate a possible link between certain estrogens and gut microbiome and suggest a metabolic benefit of estrogens through manipulation of gut-liver axis. So the first curator has labeled this dataset as a gut-liver dataset, whereas the second curator has labeled it as gut and liver data set. Similarly, for another like data set, peripheral blood mononuclear cells, they have been labeled as blood, whereas the second curator has labeled it as peripheral blood. Similarly, here is another example where a curator has labeled this data set as neuron, whereas the second curator has labeled it as somatosensory neuron. So having consistent data and labels, this can significantly improve the quality of data and model performance. Several strategies like having a double blind peer review process, so that in case there are contradictions between curators themselves, these can help in improving the label process. Machine learning researchers, they have also proposed a variety of methodologies like self-supervision and weak supervision to automate the labeling process. So we'll be covering about how to improve label quality using a variety of automation approaches in our subsequent videos. The second point is quality checks by subject matter experts. And having the correct domain knowledge, especially in biomolecular data, it is crucial for a high quality labeled data set. Subject matter experts are able to detect small discrepancies in the data that data scientists or machine learning engineers may not. So here is an example. To a normal person, fish and chips would mean a popular British dish that consists of fried fish, whereas to a biologist subject matter expert, fish and chips would mean fluorescence in situ hybridization, which is a technique for detecting specific DNA sequences on a chromosome, and this analysis is done on microfluidic chips. So having data reviewed by subject matter experts is crucial, and having the quality data checks and protocols is very important for improving the performance of the model in a data-centric approach. Next, we can talk about data augmentation. So there exist like some strategies to augment data in case the data that you have is not of good quality and there only exists a small amount of data that is of high quality. Data augmentation allows you to increase the quality of data by slightly modifying copies of already existing data or creating new synthetic data from the existing data. Although one might be aware that data augmentation is quite difficult in the context of biomolecular NLP. Few examples that can be used are replacing the words with their biomolecular synonyms, or using back translation, that is translating a text in English to a different language and then retranslating it back to English. Generative adversarial networks, or GANs, can also be used to generate a much broader set of augmented data. However, it may not be the best option to add more noisy data for training your data sets. And as was previously said, data augmentation with respect to biomolecular NLP is quite hard. The other step, which is very important, is processing your data. So a good NLP model requires clean, high quality biomolecular data set, and this data is very difficult or hard to come by. Preparing the raw data set and making it suitable for NLP models is a very crucial step. It is important that we clean the data, deal with missing values, and convert it to an acceptable format. And these are some of the best practices that can be used with respect to pre-processing the data, as well as post-processing, that can help in improving the quality of data. So like selecting sentences that end with punctuation marks like period, exclamation, question mark. Splitting a text into sentences might help in finding relationships between these sentences. Anonymizing target entities and chemical compounds, removing code from the text, cleaning text using regular expression patterns, text lemmatization, that is converting a word to its normalized form or its base root form, uh, removing stop words, making sure that the content it is in desired language. These are some of the approaches that can be used in pre-processing your data to get a good quality data, and that can be feed to train your models. So concluding this talk, we have seen how model-centric approaches have led to a creation of very big NLP models. However, now there is a necessity of adopting the data-centric approaches for creating effective NLP models in biomolecular data. We have explored a few methodologies and examples of improving data and data labels, uh, data reviews and quality checks that can be done that help us in enhancing the quality of data. Adopting these approaches on a high quality biomolecular data set can lead to the creation of customized NLP models that have superior accuracy and efficiency. Thank you for listening. If you have any questions, you can write them to us at info@elucidata.io. We have also published a blog along with this video that you can find in the description. Thank you.